sharing their experience from tech leaders to tech leaders. This is CTO Talks.
Hello, my name is Marcin Monowski, and the topic of today's CTO Talks episode is AI in SDLC, where SDLC stands for Software Development Lifecycle. And my guest tonight, Brian Wald, the Global Head of Field CTO at GitLab. Hi, Brian. Good to have you here.
Hi. Thanks for having me.
All right. Brian, could you please say a few words about your role at GitLab, what it actually means, and what do you do on a daily basis?
Yeah, absolutely. Yeah, again, thanks for having me today. Great topic, very timely, obviously, with what's going on in the industry around AI in general, but more specifically, what's happening in software development with AI as well. As I mentioned, my name is Brian Wald. I run our Field CTO organization here at GitLab. So the Field CTO team, my team operates primarily in two functions, right? We operate as a consultant, as an advisor with our largest customers and prospects out in there. Really focusing with them around the, strategic roadmap for their leadership team, how they're thinking about software development as an organization, and how they're thinking about, what their future looks like as an organization that's now enabled by software, right? And so that's the one primary function. The secondary function is really, being the, ambassadors of the brand of GitLab, being out there in the industry, understanding the trends. Timely, of course, with being AI being a big topic out there right now. Our team focuses a lot around, what does this really mean to organizations? How would they go about adopting this? Things like that. So really looking at the trends, what the next big thing is, how are we going to see improvements? How are we going to allow them to see measurements of that as well, right? And so, really close to this topic, close to kind of where organizations are looking to adopt, their practices for their next generation of their software development.
All right. So, you described it very well. AI is a very trendy topic, and it couldn't miss IT itself. The most discussions happening around this topic refer to code assistance, so code generation, LLMs, and things like that. However, before we delve into the topic, we will definitely discuss this. I would like to see or understand and maybe get some of your ideas on where do you see that AI could help in the whole, development lifecycle. And which stages it could apply to, Not only coding itself, but, starting from design up to production maintenance.
Yeah, absolutely. I think this is a really important topic. Code generation, code creation, code auto-completion tend to get the spotlight right now. And rightfully so. I think it's very well suited for how large language models operate. The way that the models look at token-based approaches, the ability to have a lot of inference from the prompts to get good responses back and to see immediate responses as well, right? So developers have rightfully so, and organizations have rightfully so looked at this as a way to say, hey, how can we increase developer productivity? How can we remove a lot of the whole low-hanging fruit that developers spend a lot of time, scaffolding things out, writing tests, things like that, right? But if you really look at this holistically, I think this is where you're going to start to see the organizations are going to see a lot more value in AI as they start to think about AI as a portion of all of the process throughout the SDLC. So if you think about the SDLC and you look at the big components of that, right? So you start with code creation or even, earlier than that even, right? So around, planning, issue creation, feature generations, architecture, looking at how AI can help, sort through key bullet points, summarizing things, making it easy to collaborate for development teams so that they can get off the ground running, writing the right code and focusing on the right things, starting from that aspect, going through the code creation. But what's really interesting that I think we're going to start to see the AI becoming a big aspect of the velocity of organizations is looking at what happens after the code's been generated, right? So once you generate code, and say you're using a tool like GitLab or GitHub or any of these tools out there to manage the source code and manage the development process, your next step is oftentimes to create a merge request or a pull request in GitHub. And when you're in these places, this is where you're doing things like testing the code through automation. This is where you're doing, review from your development team. This is where you're doing security review, going through compliance, all of these aspects where you're really starting to look at, okay, what's the integrity of the code? Are we producing high quality code? Are we producing error-free code? Are we producing secure code? And all of these areas really lend itself well to AI, to being an assistant in that process, right? So instead of having your development teams go through a review process, for example, maybe the first pass of that review process is done by AI. They look at the code you've created. They look at the bigger picture of the changes. They start to look at and assess the risk level of making a change like this, and then allowing the development teams to focus on what's really important here. If I make a change into a high risk area of code, so maybe something like authentication or something like this that may take down your entire application, I want to make sure that we're putting the right eyes on this and the right people are involved in that. So can we go and figure out who the right reviewer should be? Can we give them the tips and say, hey, this is the area you should go and focus on? And so allowing them to really spend time on the areas that matter and removing a lot of the low-hanging fruit, right? And a lot of low-hanging fruit can be done through automation and then processed through large language models, and then give you a summarization of here's where you need to go and focus. So if you look at it from that perspective, I think a lot of these security vulnerability finding reviews, the test generation, the performance generation, figuring out who should be the right reviewer of this, shepherding it through that entire process, we're going to see AI being implemented as kind of fundamental aspects of that, which ultimately speeds up the process significantly. The other point that I want to make on this is that, when you look at an entire life cycle of a change, so say something comes in from your product management team saying, go and implement this new feature. From the point where you go and implement a new feature, start coding, go through the review process, create the test, go through the security aspects, put it into a review environment, put it into staging, and put it into production, if you start to break those down into point instances, you'll start to realize that the coding portion of that process is only about 20 to 25% of the developer's time. The rest of the developer's time is spent shepherding it from code creation through production. And so if you think about this as an organization who has thousands of developers, this means that thousands of your developers are spending 75% of their time just moving code through the process and not actually writing code itself, right? So this is why we want to really start to think about how AI is uniquely positioned to help organizations and help developers move through some of the, what I would consider like low-hanging fruit portions of the development process, right? And so I think that's where we're going to start to see a lot of big changes and ultimately moving code through a production state that's high quality and secure faster.
Mm-hmm. All right, that's very interesting. So what you're saying is that like the coding itself takes 25% of developers' time. And do you have any like first stats from potentially your clients or from the market on how much you can gain in the code generation or assistance process itself? Yeah, because I mean, if it's only 20%, then potentially, the whole gain is not as significant as you may think.
Yeah, I think you're really cluing in on the important aspects of this is to really quantify, to qualify the understanding of what the increase in velocity really means, right? And so the first way that you have to really look at this, and the way I always talk to this about with CTOs and executives at organizations, is say, well, how are you measuring productivity here first? And, I can tell you historically, when I've been involved as, running engineering teams, there's been a lot of models for looking at this. There's been things like lines of code generated, or there's things like, are you creating, bugs? And if there are bugs, how quickly are those fixed? Are there security vulnerabilities? And starting to look at metrics around those things to measure productivity and understand who high performers and low performers and what teams are moving faster. You start to look at all these metrics and you start to realize, well, those aren't really great metrics for us to be measuring because there's too many variables involved. You're starting to incentivize poor behavior. We're talking about engineers here, right? Engineers are going to figure out the most efficient and fastest way of doing things. If you incentivize someone to write more lines of code, what are they going to do? They're going to go off and generate lots of lines of code. And so when you start to think about metrics of how fast and how productive is AI going to be in code generation standpoint, you may be running into a scenario where you're measuring the wrong things. And so oftentimes I think about the measurements for organizations or development process or organizations is really around, what is the time to production? So, if you look at DORA metrics, one of the DORA metrics is cycle time, so time to production, which is a good metric that does this type of thing. The other metrics you may be looking at is, how many times have you gotten something into code review, and how long does it take to go from code review into production? So it's a segment of the cycle time that I think is really important as well, right? And so back to your question of, well, how much time are we saving, or what productivity gains are we getting from code generation? The reports that are out there today that have been out by Microsoft, that we've actually done a DevSecOps study recently at GitLab as well. There's a lot of these organizations who are starting to study this. Generally speaking, what you're seeing is somewhere between 15 and 25% productivity gains, right? And so you hear these numbers, you're like, wow, that's incredible, right?
Sorry to interrupt you. Is it like this? Does it apply to the metric, like for instance, time to production, or like the only 25% of the code generation process?
Yeah, right. Exactly. So that's exactly where I was going with this, is that they're measuring, when I start a task and I start my coding inside my IDE to getting this into a state of review. So basically just the coding portion, when I'm actually in my coding IDE writing the code, how long does it take to do a scaffolding for a, function and getting it to review? And how long does it take to do that when you have an AI assisted tool helping you? When they look at those things side by side, they're saying, hey, this is about a 25% increase in velocity in this portion of the process. But as I just mentioned just a bit earlier there, well, if you're only spending 25% of your time writing code, you're only talking about 25% of that 25% in terms of overall productivity gains for the organization if you're measuring things like time to production, or that cycle time that I was mentioning a minute ago, right? And so, I think these are still incredible gains, and it's super valuable, and you're going to see more and more increase in this. But you also start to need to think about things around, well, is that a senior or a principal developer doing that? Is that a QA engineer doing that? Is this a junior, early career developer doing these things? All of these things change these metrics and variance, and the way that you utilize these tools change as well. So, even though I think there's big gains, we need to think about this holistically as what is the real end result that we're getting out of using a tool like this.
So how does the usage of and the gains vary from like junior to senior devs and QAs potentially? Yeah, it's really interesting. This is an area that I've spent a fair bit of time studying. And if you look at how a junior developer is going to go off and utilize a tool like AI, oftentimes this is going to be where they're saying, generate me what I'm trying to solve for, and then I'll go back through and sift through and start to fill in the gaps and figure this out from there, right? So they want a starting place. They want those templates. They want to have a scaffolding built out for them, and then go through and figure out, what needs to change and so on and so forth, right? Typically, when you look at a senior developer, someone who's been, writing code for 10, 15 years, their approach tends to be the other way around, where they're saying, I'm going to start developing a lot of the things that I think are right in terms of the approach based off of the architecture of what I'm trying to change here. And then I'm going to let AI come in and help fill in some of these gaps, and I'm going to validate those gaps, right? And so they use it in a very different way, both very valuable. And, I think where you start to see AI becoming super valuable for both senior and junior developers is just syntax. Hey, I'm writing this in, Java, but I got to go write this in, C++, or I need to go write this in, .NET or whatever it may be. What is the way I do this from Java to .NET in the syntax here? Things like that are really valuable and time saving from you going off to Google and searching this, doing the context switching, things like that, right? So, you're really starting to see a lot of value there from both junior and senior developers, but the way that these teams are using these are very different. And then QA engineers,
they're the ones involved with the testing process of this. So, they're the ones who are wanting to, maybe they're the ones generating the test, or maybe they're the ones validating the test, or they're the ones who are going and, augmenting the test to be more specific. They're using them in a totally different fashion because they're more focused on the testing harness for that application than the actual code itself. So looking at metrics around velocity, well, they aren't apples to apples comparisons there either. Although, I think that's probably one of the areas where I'd say consistently you're seeing really good gains, because the way that AI operates, again, with being able to look at the context of the application and to be able to generate those test results, tends to be very, very effective and gives you a really good baseline and starting place to move forward from there.
Mm-hmm. So, I mean, one of the conversations or discussions around this is like, how useful is the generated code? Because there is a risk that the AI can generate whole classes and everything, but then you spend more time on actually reworking the stuff to do what you want, rather than where you start losing all the gains. Yeah, I mean, do you have any experience with such a problem?
Yeah. So it's twofold, right? Because every AI vendor out there is going to tell you that the way that large language models work, there is a risk that you're going to generate insecure code or error-prone code, right? Because the way that those models are trained is that they're looking at all of this data that's out there, and they're training, whether they're training on open source projects or however they're training, depending on the organization who's building the models. They're training off of real people's code, and guess what? Real people's code has vulnerabilities, has bugs in them, and so when this AI generates these things, it doesn't know whether it's secure or insecure, or if it's going to generate a Stack Overflow, or it's going to generate some sort of error inside your code. And so you have to be really diligent in your process to validate and check those things and ensure that what you're doing is not actually creating bigger risk for you and your organization, or creating a poor quality code, right? And so this is where automation becomes really important as well, right? So you need to have automated tools that are checking to ensure that the integrity of your code is good, that the security of your code is good, because it's easy for humans, right? So if you were to go and look at 50 lines of code that was generated by AI, you're going to look at that, and if it looks probably about right, you're going to say, yeah, this looks pretty good. I'm going to go with this, right? I'm going to accept these changes, and I'm going to go forward with this. But it's much harder for you to identify small little pieces inside of that than it would be if you were to rewrite that code yourself. And so it's actually creating a bit of a cognitive dissonance for developers as they're getting this generation of code in front of them on how they should proceed with that. And so this is why I always talk about, let's make sure your workflow looks good and you have the right automated tools in place to check those things. And when you have that, that's when AI becomes really, really powerful, because it can generate these things, check to make sure that it's running well, and then you kind of validate and building your own business logic on top of that to shepherd it through the process in an effective way.
Okay, which gets us to the topic of this like post check-in procedures. So I mean, even before AI, there were tools, and there still exist for static code analysis. They can do certain checks automatically, as well as security checks of the code, right? So
sure.
Now with the AI, would you still suggest to use this kind of tools that's been there, that have been there for years, or maybe some new tools, or maybe GitLab has something also built in that can do the same thing but in a smarter way with AI implemented?
Yeah. So I think the workflow, I don't think changes very much from what I think an ideal workflow looked like before AI, in the sense that when you create code, that you should be running through a series of tests, whether that be your unit tests that you develop for the code itself, or the performance tests, or the security tests there. All of those things should be part of your development process. In fact, I think they become even more important, because now you have, another essentially person, if you will, an AI person who is generating some of this code that you need to also be, checking as something of your own. So it becomes even more important to have those things built into your workflow. I think where we're starting to see AI, be a factor in the, post check-in process is when you start to look at things like, okay, there was a vulnerability detected in this. I'm an engineer on this, and maybe I'm not a security expert in this particular area. Historically, if you go look at how organizations deal with this, they say, okay, try to solve this problem yourself. If you can't solve it, then go reach out to one of our application security team. They'll help you solve this as well. Well, typically, if you look at organizations, there's not very many application security folks to developers, right? And things need to move forward and things need to get into production. And so what historically would happen is that, yeah, we know there's a vulnerability. We don't necessarily know how to fix this. We're going to push this into production. We're going to create a backlog ticket that we have to go and fix later, right? And, now with AI can go and say, oh, there was a vulnerability detected. Let's go look at the CVE for this vulnerability. Let's look at the code that's inside your application and evaluate this and tell you how to go off and fix these things more effectively and potentially even develop solutions for you, right? And the next step. So even not only would you create a solution, but you would rerun the security scanner to see if that solution passed that security scanner. And if it does, then make that suggestion available for the developers. So what we're starting to see is a world where if you have a vulnerability in your code, it could potentially be a hands-off change for developers to go in and say, oh, there's a security vulnerability. Yep, I see how I go fix this. They've created a solution. This solution makes sense. Implement that, rerun the scanner, it passes, and now we're off into your next stage of your review process. Where, I think that's a huge savings time, a time saver for that. Or, the other aspect that I oftentimes see in organizations is just test coverage in general. If you go and look at the test coverage of most organizations across their portfolio, they may have their flagship applications may have good coverage. But if you look at below that, those flagships and, the other applications they have, most of them have pretty poor coverage because that takes time and they have, they're resource constrained, right? With AI, if you were to go and check in code, we can now say, oh, you created some code that has no coverage and we know your testing harness. And so we're going to go and generate some test code, the test coverage test for you that you can go and implement in your code to keep this coverage high in your application, right? So things like that are really taking off the burden of developers and making it easier for them to move things through the process and creating high quality code.
And how about like unit test generation? How does AI, perform in this task?
Yeah, and so that was what I was alluding to earlier with the QE, the QA engineers, right? I think that AI is well positioned for looking at that code and to generate those unit tests automatically for you with sometimes no tweaks, but oftentimes, some minor tweaks you'd have to make to add in some of the business logic there. But it really is a big aspect of offloading some of that time. And, whenever I talk about all these things, just to step back from my conversation earlier around, hey, you only spend 25% of your time coding. Well, we want the developers to spend more of their time doing those things. And it's not that they don't want to, it's just that there's so much other stuff involved in the process that they don't get the time to spend on those things. But if you're an organization, you want your team to be spending time making really good architecture decisions, writing really high quality code, offloading some of these tasks later in the process that they're responsible for means that they're going to spend more time writing code. So things like fixing vulnerabilities, things like writing unit tests, going through a review process. If there's a pipeline in your CI tool that fails, being able to have AI analyze the logs and tell you exactly what you should go do as the next step. These types of things offload that time they spend later on and ships that back to the development time. So they're spending more time writing high quality code on those applications, right? And that's the end goal of what I think a lot of this AI is really focused around for software developers.
And it is actually confirmed. So we have one team testing AI for code generation. What they're saying is that it takes off the boring stuff, like generating boilerplate code, like connection to the database. Yeah, this kind of
exactly
thing that's not focused on the business logic, but you need to write it in order for the things to work properly, right? So this is like what you're saying, and now I get it. Is like this. It's an augmentation. It's like an acceleration of the capabilities of the developers, right?
Right. yeah, that scaffolding code, that the greenfield, I'm spinning up a new application, AI can accelerate way more than just 25% of the development time. To getting to a MVP state of a greenfield application with AI and code creation can be as fast as 75 or even, much, much higher than that time saved to generate those things, right? Where before you say, oh, I have to go off and look at the documentation for these, this application, even using tools like Spring Boot or, on the front end, like, some of the things that you see inside Vue.js where they generate some of that boilerplate stuff for you. That's just a starting place there. When you can start to add in some of your business logic and have AI start to generate the functions around that and generate those components, it can save a tremendous amount of time. So Greenfield is an area where I think that code creation is really well suited for, and you're going to see a huge uptick in velocity of teams going through that process.
All right, you mentioned a very interesting thing about logs analysis. Yeah, so I know tools like application monitoring that can alert you of certain events happening in the logs. However, so far, as far as I know, they were kind of rule-based, or they had some, I would say, text or pattern recognition in the logs. And I'm now interested whether you know about, the tools or some use cases where AI can help do this kind of logs analysis in a smarter way. Yeah, so some kind of use haven't been there before.
No, I think, this is the next evolution of what you're seeing in a lot of these application monitoring tools that are out there today. So I'd say that there's really two sides of this where you're going to see a huge change in how AI is going to help with log analysis. There's the proactive side, which is going to be your alerting mechanisms to detect anomalies, to look at your running application and say, hey, there's some things that look like there's going to be some issues here. Here's where this is happening. Here's our root cause analysis of what's going on here. And here's how you would go off and, solve some of these things before they become a bigger issue, right? So there's the alerting aspect of this. And then there's hey, there's an issue that has happened, or something has failed inside a CI pipeline, or something has failed on my live running application. And I'm looking at logs across my database, across my, Kubernetes stack, across all these different areas. And, historically, this would take a lot of folks, with different competencies, time to sort through all these things, understand the root cause of where this is happening, and go back and, figure out what the fix is going to be here. What we're seeing with the AI tools is that because AI is so good at analyzing really large sets of data, that, we can get to this root cause analysis very, very quickly and sort through that data in a much faster fashion, right? And so I think it's allowing organizations to allocate their SRE teams and their DevOps teams more effectively, and to spend more time on, building out, the things that are going to help move things forward rather than trying to solve the problems that are happening today. So I think there's a huge change happening here. It's not necessarily anything we're doing new. It's just doing it more consolidated, more and much faster, and giving you a root cause analysis as a starting place that you didn't have before.
There's one more use case actually that just came to my mind is something like anomaly detection in the logs. So something you don't train AI for, but it can detect that the system is behaving in a weird way, an unusual way. However, I haven't seen any tool having that so far. Have you?
Yeah, I've seen a couple of them. There's been some around a while around anomaly detection when you look at logs, but also when you look at things, so one of the industries that has been using anomaly detection for a long time is banking, right? So fraud detection, things like that, where they can build out basically recipes that say, hey, go look at these types of data independently. And when you see something that these things are all kind of off in a scenario, log this as an anomaly and let our teams to go see what's happening inside there. So threat detection, fraud detection have been areas where anomaly detection has been very big. But this is also, an area I'm seeing a lot on the security side as well, right? Where, I'll give you the example that I'm very familiar with in software organizations where, they have a platform for software developers, right? Something like, GitLab or GitHub or whatever that may be. And, part of this, they have authentication mechanisms that hook into this. There's other tools that are part of the software development lifecycle where there's logins associated with those as well. And when you start to look at the landscape of your risk for, IP leakage or somebody getting access to one of these systems and getting more access to another system, all those kind of common attacks that you see out there happening from breaches, anomaly detection can become really powerful. So you could say things like, hey, this person just got logged into the application. So you can have a timestamp associated with that person. That's just normal. No anomalies there. And then that person just went in and got access to 10 other projects. And immediately that person started downloading all the source code from all of those projects, right? Now, all of a sudden, we have an anomaly on our hands of like, hey, this is not normal developer behavior when all of these three things kind of trigger together. Maybe that's a simplified version, but you can imagine, some other aspects of events happening that would trigger something like this. And so these tools can kind of look at all of these things in conjunction and say, okay, based on all 5 of these events happening in a short period of time, something's not right, and we need a human to come and look at and figure out what to do. In the meantime, we're going to go block this user and, make sure that there's no risk happening there. So you can start to do things like that, which is really powerful for organizations who have a lot of sensitive IP, as an example there in software development.
Talking about security, it's very, we mentioned this many times, yeah, but we haven't actually discussed something that is being raised as one of the biggest risks in adopting AI for code generation specifically, yeah, is that, first of all, the models need to be trained on some data, and the consent of the owner of the data to train the model. And the other one is, this is probably one of the biggest concerns of enterprises from adopting this. Yeah, what happens to my code? The one thing is what happens to my code when I use AI or LLMs to generate code, and the other question comes can you tailor the models to your organizational needs, yeah, or to your maybe best practices, some standards you have implemented?
Yeah, absolutely. I think you hit on 2 really big areas of focus for organizations as they look to adopt their AI strategy for software development. I've had hundreds of conversations in the last 6 months with enterprises, and both of these things come up in almost every single conversation, right? So the first being on the compliance and security and IP risk, right? And, every organization wants to know, hey, if I'm going to send my data somewhere, is that data stored securely? Is it ephemeral? Is it going to be used for training? I can't be having my code be used for training and then some other organization is trying to generate a function. All of a sudden they're generating code that's based off my IP. That's a huge risk, right? How probable that really is in a way that would be actually a risk is debatable in the industry right now, but it's certainly something that from a legal perspective that people are very concerned about. Most of the organizations out there who are building these models today are not training off of customers' data, right? They're always going to have a preset trained model, and they'll give you the sources for that. I'll talk about that in a minute. And then when a organization uses these models, they're only sending up their code as a prompt, and that prompt is ephemeral. And then once that response comes back to that person and say code suggestions inside your IDE, then that's deleted and is gone, right? So that code never gets stored anywhere, and it's not going to be something that is used for training. That's the number one thing that we're hearing in the industry right now. Across every organization who's doing these types of things, that's the biggest risk. I think that's, I think where this becomes a risk isn't so much of IP leakage. It's more of what is my risk to be sued, frankly, if I am generating code inside my organization based off of trained code from your large language models that I don't know was maybe copyrighted in a way that was, that I had no, as an end user, I had no idea was being used from that purposes, right? And so that's the other aspect that we hear from a legal perspective is, where you're training your code, what actually constitutes as free open source code that you can train on, and how do we ensure that there is no risk of you training on something that was private and now I'm using that and now I'm at legal risk of potentially copyright or using IP.
Or maybe
so
it's even not.
I think those are big topics out
it
there.
doesn't necessarily even need to be private, but the license, the risk,
or just the license. Yeah,
it doesn't allow you to use it for commercial purposes, for instance.
that's right. Exactly. Yeah, there's a lot of that as well, where maybe open source in the sense that it's publicly visible, but especially with the licensing changes that a lot of open source enterprise organizations are moving towards, where they're saying, you can use this as an open source code, but you can't use this as part of your product anymore, right? And so how do we know we're training on that? So a good example of that recently would be HashiCorp, using that model change on their side for the licensing. You can't embed Terraform as part of your application product itself. You can use it, but you can't use it as part of the product, right? So the change in licensing there, how does that affect your generation of Terraform code in the future, right? So there's a lot of things out there that are being looked at and trying to understand where the training is coming from, and making sure that there's no risk involved in that for organizations. And that varies across the board and how that's happening today, where the code is being trained from. I think I can tell you, generally speaking, though, most organizations are, taking the right precautions to prevent private IP being used as part of their training models. But that gets into your second question of, but I want high quality results. I want high quality results, right? And high quality results usually means either you're training off of my code inside my organization, so we're doing things the way that we're doing everywhere in the organization the same, or I want to train off of high quality code in general, and oftentimes that may not be the free open source code that's out there. There may be something that's generated through organizations. And so, there's that other aspect of this is that, just because you can generate code doesn't mean that it's good code. And, so I'll say two things on this. The first is the notion of using your organization's code for training models oftentimes is a bit of a fallacy in terms of how much value you're going to get out of that, unless you have tons and tons and tons of data, terabytes of code that you can train on, or you have a really unique language that is not, there's not a lot of data out there in the public space. So maybe like mainframe data, things like that, or code that's written for mainframes, things like that, maybe an area where you would want to train off of your own code to get better results for it. But generally speaking, with the amount of data that's out there that's open for these models to train on, you adding a supplementary amount of your code into these models to help the results come back to you is most of the time not going to give you much better results. Where you're actually going to get better results is, how are you constructing really high quality prompts? So what is the inference that we're taking from this application to ensure that the results that are coming back are high quality and very specific to what you're doing in this scenario here? So that's actually where this whole, you may have heard the term prompt engineering and that whole discipline coming up in the industry. It's all around, good data in, good data out, right? And so how do we construct really high quality prompts with the right inference, with the right data to bring back good quality results back to the organization without having to train on our own code? That's been a big aspect of the focus of organizations right now, and applications that are using AI to augment the development workflow.
So, I can refer to a case that's quite close to what I do and my company does. So I recorded one episode with Bartek Łukasik, and they use F# for their backend development, and you don't expect there to be like a lot of publicly available code to train F#, right? And they follow certain set of patterns, mostly inspired by domain-driven design. And they've done their first tests with this kind of, actually this was GitHub Copilot. And what they've said is that it learned to follow the patterns that they apply, and it actually makes their life easier, because it adjusted to the style they have in the code. So this is like quite close to what you just said. Yeah. So very low amount of publicly available code, and on the other hand, like trained models on the code, on the project code. Yeah.
Yeah, exactly. And that's, I think, a big aspect of this too is, when you have scenarios like that, how do you deal with that? And how do you create consistency? Because at the end of the day, what we're a lot of times talking about in organizations is that you've got lots and lots of applications. And if you want to, increase the performance and create high-performing teams, you want to create standardization, consistency across those teams and how they do their development process, because the more standard it is, the easier it is for teams to identify when, something is not, performing correctly, and they can fix that across all their applications, or vice versa. Hey, we've got this gold standard of how you should be developing these things. Let's make sure all the other teams are getting the same type of standard brought down to them so that they're building higher quality code than they were before. So those are big aspects that are I think AI is helping solve and propagate across different teams. But, to your point, it depends on the languages, the prompts, the inference data that goes into it to make sure that you're generating that in the most effective way. The last part of this is, organizations who simply don't have the risk tolerance to allow them to use models that are generated by some other third-party organization, and they have to create their own. This is a whole nother topic that I think is going to be a lot slower for the industry to adopt. So anyone in, public sector space or in, highly regulated industries, they're going to be a little slower to adopt these, although they are moving faster than I would have anticipated in terms of, being able to use AI. It's just how they're using that's different. Are they hosting their own models? Are they generating their own models? What is the extent of what those models can do and bring back to their teams? All that stuff is still kind of being determined and in flux right now.
All right. So, I have a few last questions. One thing is that, things like GitHub Copilot, OpenAI Codex, or Meta's Llamas, right? If I remember correctly, these are quite popular tools. But I was wondering what GitLab has to offer in the AI space. Yeah? What's there now, and what are the plans? Because I know that a lot of organizations, including ours, use GitLab for their purposes. Yeah, and I'm just probably it's gonna be quite interesting for the audience as well to understand what the plans are and what's available now.
Absolutely. Yeah. I think that's obviously what I've been talking about today around looking at how AI can impact every portion of the software development lifecycle is very well aligned with how we think the direction of what high-performing organizations are going toward with a platformed approach for software development. And so what I mean by this is that, our big bet and our focus and where we built in AI across GitLab is really around this concept that when you use a platform for your software organization, meaning you may still have other tools out there that you use for software development, but going through a single workflow inside the platform where your data is getting collected back into the platform, so you have a single data fabric, means that we can use that data as inference data, as prompt data for AI throughout the entire process. So what I mean by this is that, if you are in a review stage inside a merge request, or if you're familiar with GitHub, a pull request, then in this scenario here in GitLab, when you are running your automation and all the results come back from your test suite, your security suite, your review process comes back into GitLab at that single place, that data is in a single fabric layer. We can use that data later in the process to help with the AI inference so that it knows more context into what you're doing to move this into production. And so when you start to look at the AI capabilities inside GitLab, we've built things like summarization tools for the merge request. We have a code suggestion tool, which is the big one that we've been talking a lot about today, which is similar to Copilot. So inside your IDE, code creation, code auto completion, using natural language comments to generate functions, all of that stuff is built into the IDE. But as you move through the process, you're starting to see AI become part of that as well. And it's just natural for the developers, and it's a natural portion of the workflow. It's not a standalone feature of AI. It's AI embedded throughout the entire process. And so as you move through that process, you may have a security vulnerability. Well, we can explain that vulnerability. We can suggest a fix. You're moving from one team to another team, and you need to get ramped up into what's happening inside this application. Well, you can go into the application and highlight code and have it explain to you what the code's doing and how that works so that you can ramp yourself up much faster. We have chatbot capabilities that can follow you through the process. So as you're asking questions around, hey, how do I do this inside the CI tool, it can give you answers and use that data to help you through that entire process there. So we've really been thinking about this really holistically over the past 2 years about, again, that end result is how do we make organizations produce high quality code that's secure and get into production faster? And the way we think about that is, well, this means we have to have AI throughout the entire process and take away, as you mentioned earlier, some of those, those simpler tasks or those low-hanging fruit tasks that are just time-consuming, so developers can spend their time focusing on more important aspects of it. So we have a suite called Duo in GitLab, which incorporates 8 different features, and those features I've alluded to here throughout the code process, through the review process, through the security process, and deployment. Root cause analysis is starting to be built into it as well. So we're going to continue to build on that vision of implementing AI features throughout SDLC as we see areas where it's uniquely fit to speed up the developers. We're never taking away tasks to developers. We don't want to introduce risk. We want to augment that and speed them up.
All right, great. How do you envision the future of software development given the advancements in AI in 5-10 years? Is it going to change or?
Yeah. I think so. Yeah. I mean, you certainly, if you think about where we were just 6 months ago, I couldn't have imagined we are today. Right. And I think 5 years from now, the thing that I see shifting is really going to be the flip between the software engineer being the person, I guess you would call maybe in that the driver's seat, the one who is generating everything, to being the one who is the reviewer of everything and the validation of that and the architect of it. So the responsibilities of the engineer would be, okay, I understand our application holistically in a way that AI is not going to understand in terms of our business logic and the value to our customers and all of that type of stuff, the user experience, all of those things that you would be able to generate in your brain very effectively that AI doesn't solve, that I don't think it's going to solve very quickly in the future. You're going to be the architect of saying, here is what we're trying to solve for here in this particular feature request, for example. And the AI is going to generate all of that for you. And you as a developer is going to go through that and be the reviewer and be the sanity check and be the one who is, testing it against the business logic and those types of things. So instead of where today, right now, you write something and AI helps assist through that process, I think we'll see a flip there where AI is going to write something and you assist through the process. So we're going to see even faster velocity, but I think it's going to be a bit of a shift for the mindset of engineers and how they think about doing these types of things. That's where I see probably where a lot of this is going to head. And then on top of that, I do think, we're going to come up with more novel and more accurate ways to implement AI in other aspects of the development process to be more effective. So I think about things like microservices, where microservices conceptually is a really great idea. When you start to look at microservices in really, really large organizations, it can be a mess, right? And a part of the reason why it's a mess is you start to create all these different services, right? And so, having AI be able to contain and help understand and help, see one change affecting downstream or upstream other applications and services, all of that's going to make this process much more effective. So you're getting kind of the dream of what microservices promise, I think in the future, in the next few years, more so than we've seen really happen in the reality.
Brian, many thanks for joining me today. It's been a great conversation.
Absolutely. Been a pleasure. Thank you for having me.
All right. I hope we can get back to this in some time and see where we are.
Yeah. It'd be interesting to do a follow-up and say, hey, all these things that we thought happened, or here's where's our vision. What has changed?
Exactly.
That would be a great thing to follow up. And
we need to do that.
And in AI world, maybe that's only 6 months from now.
Yeah, because it usually goes faster than you think.
Absolutely.
All right. Many thanks, Brian.
I appreciate it. Thank you for your time.
Bye.
Have a good day.
Sharing their experience from tech leaders to tech leaders. This is CTO Talks.